Hi everyone, it's Ms. Cardillo. So today we're going to just kind of practice what we've learned so far dealing with logs and log equations. I'm going to go over just a few problems from each section if you need to take a look for the extra help if you're stuck on any of them. So you can just fast forward to each section that you need. In the first section here, I'm going to go over number 2, 4, and 8. So if we start with number 2, it says log base a of 1/8 equals -3. So remember, this here is your exponent. So I'm just going to write it as an exponential equation instead of a log. So I have a to the -3 equals 1/8. And to eliminate that exponent, I'm just going to multiply by its reciprocal. Remember, it's not its negative reciprocal, because if it was its opposite reciprocal, then you would end up getting a -1 as your exponent, and that's not what we want. We want to cancel them out to get +1. So it's just its reciprocal. So a to the -3 to the -1/3 is a, and 1/8 to the -1/3, well, I can rewrite that as 8 to the +1/3, and then that's just asking you to take the cubic root of 8. So this becomes a equals 2. The next one is number 4 that I'll go over. So always look to make sure that you have the same bases. And in this case, I do. So because I have a single log equals a single log, when the bases are the same, I can just set the arguments equal to each other. And I'm just going to solve for x. So 3 equals 4x, and x equals 3/4. And the last one is number 8 I'll go over in this section. So log base 5 of x squared minus 30 equals log base 5 of 6. Well, again, I can look and see that I do have the same base on both sides of the equal sign, which is good. So I'm then just going to set the arguments equal to each other. X squared minus 30 equals 6. X squared equals 36. Take the square root of both sides. X equals plus or minus 6. Now, remember, you always want to check your answers for all of these, okay, for extraneous solutions. And remember, if anything makes your argument negative, it's not going to work, because you can't take the log of a negative number and call it a real number. So in this case, if I plug in both +6 into x and -6 in for x, I end up getting a positive argument for both. So these solutions are both possible. So this next section should be even more of a review, where you're using the given logs to evaluate each expression. So I'm just going to go over number 12 here. Log base 10 of 490. So remember, we can use log base 10 of 5 and log base 10 of 7 because those are given to us. And remember, you can also use a log base 10 of 10 because we know that that equals 1. Okay, so when the base and the argument are the same, it equals 1. So I'm going to also keep that in mind. So I can break this down into the log of 49. And remember, my implied base is a 10 when I don't write it. So the log of 49 plus the log of 10. And we know that this here equals 1, like we just said, because the base and the argument are the same. And while I don't know what log base 10 of 49 is, I can write 49 by squaring 7, which I do know. So I'm going to rewrite this as the log of 7 squared plus 1. And remember your power rule. bring that exponent into the front, 2 times the log of 7 plus 1, and then just substitute in 2 times, instead of the log of 7, we're going to write 0.8451, add 1 to that, and I end up getting 2.690. In this last section, I'm going to go through numbers 14, 15, and 20. And these are the newer material that we've covered. So let's start with more basic. So let's start with number 14. Now, again, I'm noticing that all of my bases of my log are the same. And I'm going to write the left-hand side as a single log. So when I see subtraction, I think that it started out as division. So log base 8 of 48 divided by W equals log base 8 of 4. So now I have a single log equal to a single log with the same base. So I can just set the arguments equal. 48 over W equals 4. When I solve for W, I end up 48 equals 4W, so W equals 12. Now in number 15, I'm going to basically follow the same exact steps. So this time I need to make the right-hand side a single log. Now, whenever you see the numbers in front of your log, remember that they started out as exponents of the argument. So I'm just going to rewrite these first. So I have the log base 3 of y equals log base 3 of 16 to the 1/4 plus log base 3 of 64 to the 1/3. So log base 3 of y equals log base 3 of 16 to the 1/4, or the 4th root of 16 is 2, plus log base 3 of 64 to the 1/3, or the cubic root of 64 is 4. And again, I have the same bases. So when I see this addition here, I think it started out as multiplication. So that's how I'm going to write those as a single log on the right. So log base 3 of y equals log base 3 of 2 times 4, multiplying the arguments together. Log base 3 of y equals log base 3 of 8. So this ends up equaling just y equals 8. So I can set the arguments equal to each other at that point too. Now let's take a look at number 20. So in number 20, you'll notice the difference here is that I have this 1 on the left-hand side. So what I'm going to do is I'm going to keep that 1 there, but I'm going to subtract the log that I have in front of it and bring it to the other side. That way, I have a difference of logs that I can then form into a single logarithm. So if I subtract log base 6 of 2x minus 5, I get 1 equals log base 6 of 7x plus 10 minus log base 6 of 2x minus 5. So now I can write the right-hand side as a single log. Okay, there is subtraction, so I'm thinking it started out as division. 1 equals log base 6 of 7x plus 10 divided by 2x minus 5. Just divide the arguments. Now I have a log equation. So remember, this guy here, this 1, is actually your exponent. So if I think about rewriting this as an exponential equation instead of a log, it becomes the base is 6 to the first power equals 7x plus 10 over 2x minus 5. Now, if you're used to writing the equation with the log on the left-hand side, and it's easier for you to think about that way, then just rewrite it like this, because if you use the method where you kind of do the little swoop, or I sometimes call it the heart method, you're going from the base of 6 to the first power and it equals the argument. So if it's easier for you to rewrite it like this, then just rewrite it. So now I can actually put the left-hand side over 1, and now I'm just going to cross multiply. So I end up getting 6 times 2x minus 5 equals 1 times 7x plus 10. 12x minus 30 equals 7x plus 10. Solve for x, so 5x equals 40, x equals 8, and that does not make the argument negative, so that is my solution for that one. So these examples have pretty much gone through all the types that you're going to see on this practice sheet, and finish up the rest on your own and ask your teacher any questions you may have.